Hello and welcome. In this video, we will derive some formulas for inverse trigonometric functions. The first one is what is sine inverse of 2x square root of 1 minus x square. So we can derive these formulas by substituting some values to x. So whenever we have 1 minus x square, it is better to put x is equal to sine theta or cos theta because 1 minus sine square theta or 1 minus cos square theta, we know the value of this because 1 minus sine square theta is cos square theta, 1 minus cos square theta is sine square theta. So what I do is I'll put both the x is equal to sine theta and cos theta, and I can derive two different formulas for this. So what I do is I'll put x is equal to sine theta over here, and x is equal to cos theta over here. So if I put x is equal to sine theta, what I get is sine inverse of 2 sine theta into square root of 1 minus sine square theta. So it is sine inverse of 2 sine theta into 1 minus sine square theta is cos square theta, and sine inverse of 2 sine theta into square root and square will go, so I'll get cos theta. So you get this as sine inverse of 2 sine theta cos theta is sine 2 theta, we know. So this is equal to 2 theta. So from this I can write theta is equal to sine inverse of x. So we'll get 2 sine inverse of x. So sine inverse of 2x square root of 1 minus x square is equal to 2 sine inverse of. This is one of the formulas. And let us see what happens if I put cos theta. So if I put cos theta, I'll get sine inverse of 2 cos theta into square root of 1 minus cos square theta. So I'll get sine inverse of 2 cos theta into square root of sine square theta, and this is sine inverse of 2 cos theta into sine theta, sine square theta under square root becomes sine theta. So again this is sine inverse of sine 2 theta. So I can cancel sine inverse and sine. I'm left out with 2 theta. So from here I can write theta is equal to cos inverse of x. So this is equal to 2 cos inverse of x. So what we can conclude here is sine inverse of 2x square root of 1 minus x square. This is the case, and this is equal to 2 sine inverse of x, or this is also equal to 2 cos inverse of x. So this is one of the formulas. Let's derive other formulas. So we have what is the value of, let's take this sine inverse of 2x by 1 plus x square. So one thing we have to note here is if I have 1 minus x square, we can put x is equal to sine theta or cos theta, because 1 minus sine square theta and 1 minus cos square theta, we know the value. So whenever there is 1 plus x square, it's better to put x is equal to tan theta, because we know that 1 plus tan square theta, if you put x is equal to tan theta, this becomes 1 plus tan square theta. We know that 1 plus tan square theta is always secant square theta. So here what I do is I'll put x is equal to tan theta. If I put x is equal to tan theta, I'll get sine inverse of 2 tan theta divided by 1 plus tan square theta. So this is sine inverse of 2 times tan theta divided by 1 plus tan square theta is secant square theta. So this I can further simplify as sine inverse of 2 times tan theta is sine theta by cos theta divided by cos square theta is 1 by, I can write cos theta into cos theta. Cos square theta I've written 2 times. I can cancel 1 cos theta and 1 cos theta. So this is equal to sine inverse of 2 sine theta, and this cos theta will come to numerator, becomes cos theta. So this is sine inverse of 2 sine theta cos theta is sine 2 theta. Sine inverse and sine I can cancel. So this is equal to 2 theta. So what is 2 theta? From here I can write theta is equal to, here I can write theta is equal to tan inverse of x. So this is actually 2 tan inverse of x. So this formula is equal to 2 tan inverse of x. Let us prove few more formulas. We have cos inverse of 1 minus x square divided by 1 plus x square. So here also we have 1 plus x square in the denominator. So what I do is I'll put x is equal to, I'll put x is equal to tan theta. So if x is equal to tan theta, then theta is tan inverse of x. So this becomes cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. This I can write it as, cos inverse of 1 minus tan square theta, let me keep it as it is, divided by 1 plus tan theta, or can I write this as secant square theta, and this is equal to if I do cos inverse of 1 minus sin square theta by cos square theta, tan is sin by cos, and this becomes 1 by cos square theta. So this is equal to cos inverse of, if I take LCM here, I'll get cos square theta minus sin square theta whole divided by cos square theta divided by 1 by cos square theta. I can cancel cos square theta and cos square theta. So I'm left out with cos inverse of only cos square theta minus sin square theta. So this is cos inverse of cos square theta minus sin square theta is cos 2 theta. I can cancel cos inverse and cos. So I'm left out with 2 theta, but theta is tan inverse of x. So this is also equal to, this is also tan inverse of x. So this function is 2 tan inverse of x. Let's solve few more. Now we have what is tan inverse of 2x divided by 1 minus x square. So here what I do is I put x is equal to tan theta here. So here, because I can write this as 2 tan theta divided by 1 minus tan square theta. So this I can write this as tan inverse of 2 tan theta. I can write as tan theta plus tan theta divided by 1 minus tan square theta as tan theta into tan theta. So this is tan inverse of tan a plus tan b divided by 1 minus tan a tan b is tan of a minus b, or sorry, tan of a plus b. So tan of theta plus theta. So this is tan inverse of 2 theta. Tan inverse and tan we can cancel. So I am left out with 2 theta. So 2 theta is 2 tan inverse of x. So from here I can write theta is equal to tan inverse of x. So this function is also equal to 2 times tan inverse of x. So what I can conclude here is sine inverse of 2x divided by 1 plus x square, cos inverse of 1 minus x square divided by 1 plus x square, and tan inverse of 2x divided by 1 minus x square. All of this is equal to 2 times tan inverse of x. So this is the formula. Now let's take and this is my fifth one. So we have, what is the value of sine inverse of 3x minus 4x cube. So it we can clearly see it is 3 sine theta minus 4 sine cube theta is sine 3 theta. So what I do is I'll put x is equal to sine theta. I put x is equal to sine theta, I'll get theta is equal to sine inverse of x. So here what happens is sine inverse of 3 sine theta minus 4 sine cube theta. So this is sine inverse of, so this is my sine 3 theta formula, sine 3 theta. I can cancel sine inverse and sine. I'm left out with 3 theta, which is 3 sine inverse of x. Theta is sine inverse of x. So this value is 3 sine inverse of x. Directly we can write. Next we have sixth. cos inverse of 4x cube minus 3x. 4x cube minus 3x. So this is actually, I can write directly 3 cos inverse of x. So this I'll encourage you to do this just by putting x is equal to cos theta. Next we have tan inverse of 3x minus x cube divided by 1 minus 3x square. So if you put x is equal to tan theta here, you get this formula gets reduced to 3 tan inverse of x. So I encourage you to prove these two. In the next videos we can solve some problems. Before we go to that, I want to take few more formulas, which is sine inverse of a by b is cosecant inverse of b by a, and cos inverse of a by b is secant inverse of b by a. Finally we have tan inverse of a by b is equal to cot inverse of b by a. So in the next video we will solve some of the problems on these formulas. Thanks for watching.